Today's video will explain the adapter design pattern. Hello, I'm James Helfrich. There are four types of interface design patterns: the adapter, the bridge, the proxy, and the facade. Today's video will describe the adapter design pattern. An adapter, also known as a wrapper, is a class exhibiting the interface that the client expects, while also containing a class that the client needs. So we have three parts. We have the client, we have the adapter, and we have the provider. Let's talk about these in turn. So the client consumes the interface provided by the adapter. And for the client code to function as it should, it communicates with the provider using the convenient interface provided by the adapter. So the provider has the functionality the client needs. However, it does not have interfaces that the client expects. In other words, the client needs the functionality of the provider, but it would prefer to be in a more convenient format. So the adapter's role is to take the functionality provided by the provider and then present it to the client in a more convenient format. Now, the key difference between the adapter design pattern and other interface design patterns is this: the provider already exists and cannot be changed, and the client's needs are unchangeable and known. And so the purpose of the adapter is to translate the provider's interfaces into the client's interfaces. So let's take a look at an example. Consider the stack, the first in, last out data structure. So the stack has a class name called the stack, and we're going to have, of course, a constructor and a destructor. We're going to be able to copy a stack. We're going to be able to determine the size of the stack and know whether it's empty. Now, critically, stack has three interfaces which are unique to the stack. The first one is push. I want to be able to push an arbitrary element of type T, which means this, of course, is a template interface. We want to be able to pop an element off, and we want to get the top element, which is also a T. Now, how am I going to implement this? Well, the simplest way is to have an array as the underlying data structure. But what I could also do instead is I could have a list as the underlying data structure. Or maybe I can have a vector as the underlying data structure. Or maybe I can even have a deck as the underlying data structure. Now notice that the vector, the list, and the deck already exist and we cannot change those. And the purpose of the stack is to articulate the deck, the list, and the vector's interfaces into the format the client expects. So this is a classic adapter scenario here. Now, the C++ implementation of the stack goes one step further because it allows the client to specify the underlying data structure. So now I can say elements is not just a deck, but it could be a container where the container is a template. And this means I do not have a deck by composition, but rather I have a container by composition. So let's take a look at how that works. So for an example, I can create a stack of integers. And right now, the client through stack default will be able to access the common interfaces push, pop, and top. At this point in time, the client is unaware of the underlying data structure. And that's one thing that abstraction allows us to do, is allows us to hide unimportant implementation details, such as how I actually store the elements. The client simply doesn't care. The client can also specify in C++ we want the underlying data structure to be a vector. Now, all the interfaces will be exactly the same. All the functionality be exactly the same. It's just the underlying data structure is different. And the same is true. I can specify it as a deck. I can specify it as a list, or I can even specify it as a my list, as something I create. Now, C++ calls this a container adapter. Why? Because it's the adapter design pattern applied to a container. In this case, we're allowed to specify the underlying data structure. Now you can learn more about the adapter design pattern in the adapter section of the interfaces chapter of the software design textbook.